Okay, good afternoon to everyone who is just joining. I apologize, as you probably noticed, there are just some slight issues going about. So at this moment of time, do bear with me. Give me a thumbs up if you can hear me, and if you're well, just so that I can see the chat is working for the time being. Whilst I just get my face sorted. Apparently, I cannot see myself. Let's see. So, if you're in the chat, please give me a thumbs up, okay? And we will try and get things going as quickly as possible. At this moment of time, the only thing is that I can't... Let me know if you can see me, guys. If anybody is there. So whilst I just get myself set up, still having some trouble to do with the webcam. Okay, bear with me guys whilst I just sort this out. Apologies. Hi there, welcome to Math Squads with Yusuf, myself. Right, at this moment of time, webcam seems to be having an absolute nightmare, so I do sincerely apologize for that. What I am gonna say is, if you're in the chat and you can hear me, just give me a thumbs up, and then what I'm gonna do is we're gonna try our best to cooperate at this moment of time, and then if the webcam begins to start working and feels like it's wanting to help me, then well, that's brilliant, and we'll go with that. Okay, but at this moment in time, it doesn't seem to be cooperating, so we will just hope it does in the very near future. Okay, right. Just gonna wait for a couple more people to join. How we all been? Hi guys, welcome. Just as people are filtering in, just giving you a heads up on what the situation is. Just trying to get my webcam sorted. In the meantime, what I'm going to do is I'm going to have some starter activity questions on the board. Guys might as well have an attempt at these. Okay, then we'll proceed in a couple of minutes time. Let's let some more people come in. I hope everyone is well and having a fantastic week and half term. If you're off school, if you're still at school, then hope you're working hard and everything is well. Okay, give me some sort of indication if you can hear me, and if you can see me, that'll be great. Sorry, I know you can't see me. I'm just having some trouble with the webcam, trying to get it working. As long as you can hear me, that's the main thing at this moment in time. Give me a thumbs up if you can. Say hello. Tell me how your day's been. Tell me something about yourself. Whilst we just let some people filter in. I'm currently at my university. Just, it's exam season for myself as well as a university student. It is intense, so just trying to make the most out of it. I hope you guys are too. It's a lovely day today. Where I am anyway, so it's a nice day to be doing some work and some maths. So, just as I said, we'll wait for a couple people to come in, a couple more people, and then when we have a good enough amount, we will proceed and continue. So, as you've probably read, the focus of today is going to be on simultaneous equations, where we will talk about the different scenarios in which you will be asked questions on simultaneous equations, as well as just an insight as to how they work, what they mean, and some real life examples maybe if we get onto that at the end. So yes, again, say hello. If you're in the chat, how have you been? How's things going? Okay, what have you been doing today? Have you explored the wilderness? Maybe spent some time in the sun. I know I wouldn't be able to. I am a terrible person when it comes to dealing with a certain pollen in the air. So going outdoors is not the most sensible idea for myself. Those people who suffer from hay fever could relate. I bet. Okay, those who can't, well, just know you are extremely blessed to not have such an allergy. Okay, and of course, if you want to maybe put your answers in the chat, put your answers, see if you've got it correct, and as more people come in, we'll proceed and have some time to go through simultaneous equations. Okay, seems to be no one in the chat, so. Hi guys, if you're just tuning in, hope everyone is well, hope everyone's doing well, had a good day, had a fabulous day. Just a quick recap on what's happening. If you've just come in, please give me a thumbs up just so that I know the chat is working. Okay, and just a couple of star activities on the board while we do some things on simultaneous equations. All right, I'm just going to check if the chat is actually working. Yes, chat seems to be working. Okay. Yes, put your messages in. Just give me a thumbs up if you're live, if you can see what's on the screen. A couple of star activity questions. I do apologize. I'm having some mad trouble with the webcam this morning. So, I mean, hopefully at some point, if it decides to start working, you might be able to see me. Fingers crossed. If not, I do sincerely apologize, but hopefully you can hear me, and that is good enough. I mean, hopefully I'm not too loud for you. Okay. So yeah, as I was saying, couple star activity questions on the board. Once you have ascertained some answers, if you want to plug them into the chat, see if you've got them right, and then in a short while we'll get going. Okay. It is important, guys, that you do contribute in the chat, just so that I know where we are at and how we're doing, as well as just making sure everyone's keeping up with the pace. Okay, so for now, if you could just say anything, just say, what your name is, maybe one of your hobbies, maybe a pet name that you have, or a pet, sorry, and their name. Okay, right. What we're gonna do, I think we're gonna proceed with the actual lesson and have an attempt, and I basically get an idea of where we are at when it comes to simultaneous equations. Okay, right. Start activities were on the board, but I don't think anyone has managed to. Well, the ones that are here, if you quickly want to jot these down, but actually it's fine. We're gonna move on anyway. Onto the focus of today, which, if you can see on the screen now, is simultaneous equations. Okay. So here is an example question on simultaneous equations. What are simultaneous equations? Well, essentially, we have, you know how in algebra we have letters that represent different values of numbers. Okay, typically in algebra, you have an x that represents something, you have y, but letters can be anything, and they can represent various values. When it comes to simultaneous equations, you actually have two different letters, or two different variables is what we like to call them. And we're not told the values of any of these. The only thing we are told or given are two combinations of these variables. So as you can see on the example in front of you, we have x plus 2y is equal to 6 and x plus y is equal to 2. What does this mean? This essentially, we're talking about, we have a value for x, we have a value for y. If we add them together, we get the value 2. And if we add x to 2 lots of y, then we get 6. So use this information to calculate what x is and what y is. Now, x and y, as I've said, they can be anything, but once you narrow it down to these two equations, there is only one value x can have, there is only one value that y can have. Okay, so how do we go about answering this question? So, first things first, you need to ensure that, oops, let me just change colors, let's go with red. So, the first thing that you should really think about when you're doing these types of questions is the following. So ensure the coefficient of x, okay, or y, okay, it doesn't have to be necessarily be the first variable, of x or y is the same in both equations. Okay, so how does this actually translate to what we have in front of us? Okay, right, let me see it do. Hopefully you can see all of this. I'm just going to zoom out ever so slightly. Okay, I'm actually going to put it down here. Okay. Right, give me a thumbs up if you can see my writing. I am trying just to zoom out a little bit just so you can see everything. If it is still a bit of an issue for you to see, let me know. But yeah, this is where we are. We are talking about the coefficient of x or y. Okay. So what do I mean? What do I mean when I say coefficient? When I say the word coefficient, what sort of what bells ring in your mind? Okay, what's going through your mind? What does coefficient mean? Okay, maybe I'll give you a couple seconds to think, and then we'll proceed. Okay, coefficient of x and the coefficient of y. So, the coefficient, when we're talking in algebraic terms, the coefficient refers to the number in front of the letter or the variable. Okay, so in this scenario above, the coefficient, okay, let's see if we take our x's, okay, there's no actual number in front of the x, but we know in algebraic terms this means that there's like a invisible 1 in front of the x variables. Okay, so that is the coefficient. That's what we're talking about when we say coefficients. Okay, similarly, if we look at the y variables, okay, the first y variable in the top equation has 2 as a coefficient, and the second one has a 1 as a coefficient. Okay, so they are different. So the coefficients for the y variables are different in the two equations, but the ones for the x are the same. And that is all that matters. As long as you have the same coefficient for at least one of the variables, then you're sorted in being able to answer this question. Okay. So that is our x coefficients. Right. What you're doing is, for the variables that you have the coefficients the same for, okay, then you are looking at their sign. Are they positive? Are they negative? In this situation, okay, our x in both equations is positive. Okay. So what does that correlate to? Well, basically, if they have the same sign, what does that mean? What are we instilled to do then? That basically means that you need to subtract the two equations. Okay, so we're going to subtract the first equation from the second equation. And when I say subtract, we're just going to subtract the corresponding parts of each. Okay, so the x terms are going to subtract each other, the y terms are going to subtract each other, and then the integers at the end are going to subtract each other. Okay. Once we do that, what do we get? So I'm just going to rewrite it up here, just so that we are able to see. So we have x plus 2y is equal to 6, and x plus y is equal to 2. Right. And then I'm going to change color for you guys to see what happens. Okay, so what happens then? Well, you know, x minus x, they just cancel out. So we'll get 0x there. Okay, you can put a 0x if you want, but they will always cancel out. And that is precisely the reason why we want the coefficients for them to be the same at the beginning. Because if they're the same, when it comes to actually subtracting those, they'll cancel out. Okay, and we'll be just left with our y variables. Okay, so at this moment of time then, we just do 2y minus y. Okay, and if you do that in your head, every couple seconds, you should get plus 1y. Okay, and again, within algebra, 1y is the same as just writing y on its own. And similarly, okay, we have 6 minus 2, which is 4. Okay, so just to rewrite this equation to get rid of the messy bits in terms of the x, okay, well, 0x is just 0, so we don't need that really, do we? So essentially what we end up with is y is equal to 4. Okay, y is equal to 4 is our answer for the y variable. Okay, and then what we go ahead and do is, let me just move over. Okay, bullet point 3 is when I say sub, I'm talking about substituting. Sub in value of y in any of the original equations to find x. Okay, so we're going to sub in our y. We're going to sub in our y value to find the corresponding value of x. Okay, so this is important. This is what we're going to be subbing in. This here. So we have, if we sub in, I mean, again, it doesn't really matter which equation you substitute into. You can sub it into the top one, you can substitute in the bottom. As long as you do your maths correctly, there should be no issue in terms of you should get the same answer for x. Okay. Okay, so let's do that then. So again, I'm going to change color. Let's go for blue again. So we have, I'm going to sub into the second equation. Okay, so the second equation, if you recall, was x plus y is equal to 2. Okay, now we know our value of y. We know y is actually equal to 4. So then we can replace the y with 4 and rewrite the same equation. And at this moment of time, you now, okay, in terms of concepts and methods to do with simultaneous equations, you have done everything that you need to do for simultaneous equations. Now it's just a case of rearranging an algebraic equation. If x plus 4 is equal to 2, what must x be? Well, that's relatively straightforward for this example. You're going to subtract 4 from both sides, and you should get the value x is equal to negative 2. So again, this is your second value, okay, or your value for x even. In fact, I'm just going to highlight it as that's what I did for the y value. And that is it. You have simultaneously answered the question on simultaneous equations. Okay. And that is that essentially. Okay, so there are quite a few steps with this, and generally speaking, students tend to remember the steps. It's just the intricacies of the method. So things like making sure your coefficients are the same. Things like making sure you're subtracting the equations, not adding the equations, and so on and so forth. Just these tiny intricate details. Some people call them silly mistakes, but I don't like to use the word silly. But those minute errors that might be made just by overlooking something really tiny in terms of detail. So that is the most common mistakes that people make with this type of question. Okay. If you're in the chat, I do apologize. Sorry, if you're in the chat, I hope you're well. I hope everyone's doing really, really good. Thank you for tuning in. They have been having some issues to do with the webcam, so I do sincerely apologize. I promise next time you'll see me in the flesh, and I'll try my best to look pretty that day just for you guys. But yeah, I do apologize. I just had some issues with the webcam, so I do apologize. Okay, so what we're going to do is we're going to move on to another example, and that is the following. Okay, similar type of thing here, but this time, rather than the first terms being having the same coefficients, there is actually the second terms that have the same coefficient. Okay, so if some of you are feeling confident, I'm more than happy for you guys to make a start already. Okay, see if you can have a crack at this. And then in about 15 seconds time, I'm going to proceed and go ahead with answering this question. Okay. So remember, it is the coefficients of the f this time, which is the second term, that are the same. So what happens in this situation? What happens? Let's proceed then. Okay, so what happens is the following. Okay, we're going to subtract again because the f coefficients, which are the same, are both positive. And remember, same, so I'm going to make a note up here. We say same sign is equal to subtract. Okay, hopefully you can see that. Same sign is equal to subtract, which means if the coefficient of f in both equations are the same and they have the same sign, then we're going to subtract. And that is indeed the case. So let's subtract our equations. Okay, this is what I was talking about when I said the intricate detail. This is where people are prone to making mistakes. So we have e minus 6e. Okay, because we're doing top subtract the bottom. If we do top subtract bottom, we actually get negative 5e here. Okay. Negative 5e. Okay. And once we get negative 5e, we're going to do the same on the other side. 7 minus 10 is minus 3. Okay. Now you might be thinking, we've got a funny looking equation. Negative 5e is equal to minus 3. How on earth are we going to go about solving this? You're probably right. It is slightly peculiar because we're going to end up with a decimal here, but that's absolutely fine. It's very possible. I would actually argue it's more likely that you will probably end up with a decimal or some sort of fraction or negative value even if you were to be assessed on simultaneous equations. So let's go ahead and solve for e. So e is actually equal to negative 3 divided by negative 5. Okay. And if you do this on your calculators, of course you're allowed calculator, or even, it could come up on I don't believe it'll come up on a non-calculator. I mean, if it does, they'll give you nicer numbers. So this basically, we end up with 0.6 here. So E is equal to 0.6. And as always, we are going to substitute in this value into one of the two original equations. Which equation is that going to be? Again, entirely up to you. If you choose either one based on the accuracy of your mathematics, you shouldn't have a problem. You'll get the same answer. Okay. Again, I'm going to choose to sub into the first equation because in the first equation, I don't have to multiply E by anything. So E is on its own, so it might make my life a little easier. Okay, so we then have 0.6 plus 2f is equal to 7. We subtract our 0.6 and then we end up with 2f is equal to 6.4. 2f is equal to 6.4. Now this might be something that you're probably used to seeing in terms of solving equations. At this moment of time, you simply divide everything by 2, so you get the value of f to actually be 3.2. Okay, so these are your two values for E and F. Hope that is clear, that is concise, and you're able to understand. Okay. Any questions, pop them into the chat box and I'll be happy to answer those for you guys. If no questions, what I would like you to do is have a look at the next set. Okay. Now this looks slightly different, primarily because of the fact that we now have a plus sign. Okay. But in terms of the methodologies that we use, nothing really changes. Why? Because the coefficients of x are the ones we want to make the same. Okay. And the coefficients of x have the same sign. So again, we have a same sign scenario. And what do we do when we have the same sign? We subtract. Okay. So, give you a couple minutes. If you can go about answering this question on simultaneous equations. X plus 3y is equal to 13. X minus y is equal to 5. And then we'll discuss answers in a short while. Okay, for anyone who's joining late, welcome to the stream. I hope you guys are all doing well. And you've had a lovely day. And if you're on half term, I hope you had a very enjoyable day. Maybe you went outside, maybe you just spent some time with family, or you just stayed at home. You know, what do you guys do nowadays? I don't know, play some video games, yeah? Or just did some relaxation, because that is very important at this moment of time as well, especially when it is when it's sunny and warm outside. Okay. Okay, so as mentioned, we were talking about the coefficients of the x variables. Okay, and again, the coefficients of the x variables were 1 and 1. Okay, and again, x is positive. Both of them are positive, so we're going to subtract again. Subtract these two. X minus x is just 0. 3y minus y. Okay, so there is where you have a double negative, in which case you have 3y and you're subtracting negative y. And you know, whenever we have, oops, let me just write it a bit closer so you can see. So 3y minus y. Okay, hopefully you know, whenever we have a case of there being two negatives, they cancel each other out and they make a positive. Okay, oops. So they'll just make a positive. Okay, so that's what's actually happening here. Therefore, we get the value 4y. Okay, 4y, and then we do 13, subtract 5, and that gives you the value 8. Again, nice little equation, just algebra, okay, that we need to do. So y here is equal to 2. Y is equal to 2. What is x equal to then? Okay. Now, in this scenario, again, it's up to you wherever you choose to substitute into. You can sub into the first equation or the second equation. Personally, again, I'm going to choose to sub into the second equation. So we have x minus y is equal to 5. Okay, but now we've established that y is 2. So x minus 2, this is equal to 5. So if x minus 2 is equal to 5, what does x have to be? X has to be 7. Okay, so these are our key values for this type of question. Okay, one thing I forgot to mention at the beginning is you can actually verify if these values for x and y are correct by subbing them in to the equation above. Okay, so when I say equation above, I just mean the other equation. So x plus 3y is equal to 13. Okay, when you sub in x and y into that equation, do you actually get 13? Okay, if you do, then you've done it correctly. Okay, again, another one for you guys to try. I'll give you a couple minutes head start, just so that you can figure out what you need to do, maybe have an attempt, and then we'll go through the answers. Okay, again, fear not, but there are some negatives involved, so be careful with your negatives. Remember, 2 negatives make a positive, and whenever you subtract, I mean, there is no multiplication, but 2 negatives multiply make a positive as well. So, but yeah, there is no multiplication here, so you don't need to worry about that. Okay, so how would we go about answering this? Again, it's same sign, so we're going to subtract the x. Okay, it is the x that has the same sign, so we're going to subtract. So minus y minus 2y. Okay, again, it's a bit of a tricky one, so I'm going to write it here. So minus positive 2y, so it's going to be minus 2y. Okay, this would be minus 3y, so then that's what this becomes. And 8 minus 7. What is that equal to? We have 2 negatives, so remember they cancel out, so this is going to become a plus. So we have 15. So minus 3y is equal to 15. Okay. Minus 3y is equal to 15. What should we do in this situation? Again, I would divide. So take the negative 3 onto the other side. So 15 divided by negative 3 is your value for y. Okay, again, you can do this in your calculator, but if you're arithmetically very quick, then you should get negative 5. If you did it in your head as well. Negative 5 is your value for y. Okay. So what is our x? Which one should we sub into? I'll sub into the first one. So we have x minus y is equal to 8. Okay. We know that y is equal to minus 5. So x minus, so let's sub our value of y in. So minus 5 is equal to 8. What do we have here? We have 2 negatives again. Okay, so you're probably getting the idea, and correctly so, that when it comes to simultaneous equations, you have to be very good at recognizing what to do with different scenarios in terms of negative numbers. X minus minus 5 is x plus 5. So rearrange this, you should get x is equal to 3. Okay. Hope that makes sense for everyone. Hope that is relatively straightforward now. terms of what you need to do when you have a question in regard to simultaneous equations. And what we'll do is we'll move on to some more. Okay. Couple minutes. Have a go at this. And then I'll show you the steps that you would need to take to answer this. You don't be put off by the fact that x is now has a coefficient of 4. Remember, the process is still the same. If your x coordinates have the same coefficient, that's fine. You just need to be aware of the fact that if the coefficients have the same sign, then you subtract the equations. If they have different signs, then you add the equations. But at this moment in time, we're just dealing with same sign simultaneous equations. So, how should we go about doing this? Well, we have 4x minus 4x. Again, that's just going to cancel out, so I'm not going to write that. It's going to be 0. Negative y subtract minus 3y. Okay. What would this be? Hopefully you recognize that the double negative makes it a positive, so it's going to be minus y plus 3y, which is just 2y. Minus 1 minus 7. Again, that would become negative 1 plus 7, which is 6. Okay. Hope that makes sense. You can see why. Therefore, if 2y is equal to 6, y must be equal to 3. And that is our value for y. I'm going to sub into the first equation. So we have 4 lots of x. Subtract y, which has to be equal to negative 1. We know our value for y is 3, so that means 4x minus 3 is equal to negative 1. Okay. So we need to do some rearranging here. First and foremost, I would take this 3 to this side, so we have 4x is equal to, because it's being subtracted on the left-hand side, when I take it over to the right-hand side, I'm going to add it. I'm going to add it, so it's actually going to be negative 1 plus 3, and so I get 2. And lo and behold, same as always, whenever you have a situation like this, all you need to do is just divide by the coefficient of x. X is equal to 2 over 4, or if you want to simplify it, it's equal to 1 over 2, which is 0.5. Okay. In an exam situation, you can leave it either as a fraction or as a decimal. Either way is fine. Either way is acceptable, and you will not lose out on any marks. So that was this question. Okay. And it's very much possible for you, like we had in this situation, you might have one integer value, and then the other value might be a decimal, okay, or it might be a fraction. And that's very much possible, and that's fine. Because at the end of the day, if you sub these back in, they will satisfy the equations above, and that's all that matters. Okay, so what we are going to do now is we're going to quickly have a look at a situation where none of the coefficients are actually the same. What do you do in this scenario? Well, let's have a look. We have 3x plus 2y. In the first equation, the coefficient of x is 3. And in the second equation, the coefficient of, in the first equation, the coefficient of y is 2. Conversely, if we look at the second equation, coefficient of x is 2, coefficient of y is 1. Okay? So immediately this stands out to the rest of the questions because we don't have the same coefficient for any of the variables. And this is where a property comes in of simultaneous equations that you can utilize. And that is, you can multiply equations up so that they have the same coefficient. Okay. So what I mean by that is, if you consider the coefficients of y, we have 2 in the first one and the second one is 1. You'll notice that to go from 1 to 2, all you need to do is multiply by 2. So if we multiply just this second one by 2, okay, what happens to it? We'll have the same y coefficients. So we can use this property, and once we use it, we can go about solving it like we've solved every other simultaneous equation question. So the first one obviously just remains the same. So 3x plus 2y, we're not changing that, is equal to 16. And then we're going to multiply the second one by 2. So, but remember, everything in the equation has to be multiplied by 2 then, just to make sure things remain equal. So it'll become 4x plus 2y, and you should get 18 here. And as we were looking beforehand, we now have an equation which has identical coefficients for our y variables. So what we're going to do, we're going to consider the signs of those. Okay, both the y coefficients are positive. So that means we're going to subtract. Okay, triple S, another way I like to think about it, same sign, subtract, triple S. Okay, 3x minus 4x, okay, that's going to give you minus 1x, or I just like to call it negative x. And then 16 minus 18 is going to be negative 2. Okay, so if negative x is negative 2, then that means x has to be 2. Okay. Let's draw a line there. So that's our value for x. And then we're going to find the corresponding value of y. So I'm actually going to sub into this equation. Okay. Again, it doesn't matter. You can sub into either one, but I'm going to choose to sub into there. So we have 2x plus y is equal to 9. Okay, but we know x is 2. So what are 2 lots of 2? 2 lots of 2 are actually just 4. So 4 plus y is equal to 9. Okay, and of course, as always, we're accustomed to seeing things like this now. So whenever we have a situation like this, we just want to make y the subject, which means get y on its own. So we have to get rid of this 4. And we do so by subtracting 4. So y must be equal to 5. And that is that. Okay, so if you ever see a simultaneous equation question in which the coefficients of the x's and the y's are different, none of them line up, none of them are the same, please do not go panic mode. Just remain calm. Just remember, you can use a little trick in which you multiply the equations and you can actually get the coefficients to be the same then. Okay? Okay, for any of those wondering, okay, you could make the x coordinates the same as well, or the coefficients, sorry. You can make the x coefficients the same, okay, but you would have to multiply the first equation by 2 and the second equation by 3, okay, because 2 doesn't go directly into 3, so then you have to multiply up to a common multiple, okay, which would be 6. And then after that, everything remains the same. Right, to finish off then, as we've only got a couple minutes, I would like you to have a go at this question, okay? This question. And the hint I will give you is now we have, so my advice would be make the y coefficients the same, okay, because that only involves multiplying the second one by 3, okay? But now, remember the coefficients, once you multiply the second one by 3, the coefficients of y will have different signs. So when they have different signs, we don't subtract them. Okay, so if we don't subtract them, what do we do? Okay, lovely stuff. Then what we will do is just go ahead and answer the question. So as I mentioned, we're going to multiply the second one by 3. So we have 4x plus 3y is equal to 16. And for the second one, we then have 15x minus 3y is equal to 3. This is what we should have got, hopefully. That makes sense. Why? Because we times the 5x by 3 and we times this by 3 as well, okay, as well as the y. We'll do our subtractions. 4x minus 5x is negative 11x. Okay, obviously the y's cancel out. 16 minus 3. Ooh, looks like we're going to end up with a rather fancy looking 13. Is that our answer? Just going to double check. Oop, yes, I have made the very schoolboy error. Okay, sorry, I was giving you guys the tips and I forgot to follow that tip myself. Silly, silly me. Okay, remember, see, do not be like Yusuf. Do not be a numpty who looks at the signs, who said to themselves that they're going to actually add the equations and then they go ahead and subtract them. Okay, we're going to add this. We're going to add this equations. 4x. Why? Because the signs are different here. Okay, so 4x plus 15x gives us 19x, and these two will cancel out. So, and add this, we get 19. Okay. This is nice and easy because if 19 times x is equal to 19, then x has to be 1. If x is 1, what will our y be? Okay, I'm going to sub into the second equation, which is 5x minus y is equal to 1. We know what x is. X is 1. So 5 times 1 is just 5. So 5 minus y is equal to 1. That remains there. And then we're going to get rid of this 5. 5 we're going to get rid of by subtracting. So then we're left with negative 1 is equal to negative 4. And therefore y is equal to positive 4. Okay, because the negatives sort of cancel out. Okay, sorry if you did manage to catch that. I'm going to try and zoom out just so you can see everything. This is what we ended up with. Y is our value 4 and x is the value 1. Lovely jubbly stuff. And that is a bit of a crash course on simultaneous equations. Okay, I hope you managed to find that helpful. I hope you gained some knowledge of simultaneous equations and how they work and the methods that we use to answer them. Okay, please come stick around. If you have any questions, obviously I'm still here for a couple more minutes. If you have any questions to do with your maths, to do with something you're struggling on, it doesn't have to be related to simultaneous equations. It could be anything to the subject. It wasn't too long ago that I was at school myself, so I completely understand the pressures and the sort of burdens you have when it comes to the different aspects of your school life. Okay, and I respect you 100%. Okay, I have massive respect for you guys for being able to deal in such hot weather as well. Okay, so but yeah, so if you have any questions, any concerns, please feel free to message me in the chat box, or please feel free to contact me on my tutor. But other than that, guys, it's been an absolute pleasure. Okay, thank you so much for joining. I hope you learned something good. I wish you the best of luck on all of your endeavors this week. Okay, relax, revise hard, obviously, but find some peace and some time for yourself as well. Okay, I'm going to sign off there, guys. It has been Yusuf. Thank you so much for joining. All the best, and I shall see you next week. Cheers. Bye.